thank you all for coming. My name's Dave Stockton. I've given this talk a whole lot of times, so if you happen to be around Denver 4 years ago, you might have seen the exact talk almost. But I added some new stuff and changed some things. How many people would say that they are familiar with regular expressions? About comfortable with regular expressions? Like it's your go-to tool. No? Okay. So let's talk a little bit about what they are. So if you're here and you're not a PHP programmer, that's totally cool. There's very little PHP in this. It's mostly about regular expressions. But let's figure out what they are first, right? So regular expressions are patterns that we use to describe text, and we can use those patterns to do all sorts of things, right? So, but let's break it down a little bit more, right? So first of all, regular expressions, they are regular, right? They're not irregular. There are such a things as irregular expressions, but regular expressions have certain rules and certain syntax and certain things that we have to follow, and because of that, you can't necessarily match everything, but you can match a whole lot of things, right? Regular expressions are extremely powerful, right? Does anybody know what that is?
Oh yeah, that's a mantis shrimp.
That is a mantis shrimp, and they're freaking awesome. They're extremely powerful, right? They can see boatloads of colors more than we can see. They have these claws that kind of bend backwards, and they punch so fast it causes a vacuum to form in the water, which allows them to break the shells of whatever they're trying to eat. They can punch through test tubes underwater, and these are little creatures, and they can punch so hard they can break glass. So they're powerful, right? Regular expressions are often abused, right? This is spray paint. It's very useful, but it's also often abused. So as I've been doing for a number of years, because I've given a talk like this or similar to this for a very long time, I will open with the regular expression joke, which you've probably heard, right? So a programmer has a problem. They say regular expressions are the solution. Now they have more problems. Right? All right, so how do we use them in PHP? Well, we've got all of the preg functions, and there's a bunch, and we'll go through them. And what that means is Perl-compatible regular expressions. And it is probably, out of all of the regular expression systems, the most common one. PHP also had ereg functions, but the ereg functions got deprecated in PHP 5.3 and removed completely in 7, right? So hopefully everybody is on, not 5.3 anymore. Is anybody still on 5.3? 5.4? 5.5? A little bit? 5.6? 7 and above? 7 and above is where you should be. Everything in 5 is not supported except for possibly security stuff. Even 7.0 is no longer supported, so get the upgrades. They're super great. They will save you time and money. All right, so let's talk about the functions. First of all, we've got preg match, which is going to search a subject for a match. There's preg match all, which will search a subject for multiple matches, so you might want to find all of the phone numbers in a document or all of the email addresses in a document or whatever, not just one of them. Preg replace allows you to find a pattern and replace it with something else. Preg split means that you can split a string based on a pattern. There's one that's not in here called preg filter, which is pretty cool too. I recommend you check it out, but it is fairly complex in what it does, but it's also kind of awesome. We've also got preg replace callback, which means that you can take your pattern, you can find it, you can run it through a function, and the result of that function can be used to replace whatever you found, right? You've got preg grep, which will return an array of elements that match. You've got preg quote, so if you are, for some reason, and I don't recommend this, taking user input and running it into your regex, you want to run those through preg quote, because certain characters have certain meanings in regular expressions that normal people might want to search on, and programmer hackery type people might want to use to break your application. So it's kind of like SQL injection, but it's regular expression injection. And then if something goes wrong, we have preg last error, which gives you the error code of the last regex function. Any questions so far? There's nothing in the Google thing, which is pretty awesome if somebody wants to try it out. So, all right. The other thing you could do with the Google thing, which I thought is pretty cool, and this is all brand new stuff for me, you can put the thing on there, you can say this is a public question, and then everybody else who's on that URL will see it and they can vote it up or down as well. So it's kind of neat. All right, so let's start with a nice simple pattern, right? So we've got you know, / open brackets some stuff, and then I think you jangle your keys by the modem, and then some line noise comes out. And all right, so let's see what this does, right? So it says we're matching letters and numbers, a plus sign, equal sign, dash, dots, underscore, another equal one or more. Then we're following by an at, right? So all of this first part here is that bit there, and the at sign matches that, right? After that, we've got more letters and numbers and dashes, and then we've got a dot, and then we've got 2 to 4 letters, right? So what is this? No ideas? What's that? An email address, right? So it's an email address, but, well, I mean, it's some email addresses. It's not all email addresses. I have, fortunately, the real regex that you need for all email addresses. And I've written it down here, and I can post these online. And if you go to SlideShare, it's on there. So if you want to validate email addresses, this is the regular expression. Actually, this is the first part of the regular expression. The rest of it is over here. But that's the one, according to the RFC for email, that will actually validate regular expressions, right? So how do we do that in regular expressions? We don't. That's a terrible, horrible, very bad idea. Don't validate email addresses using regular expressions. Use something else that's made to validate email addresses, right? Because even the people that wrote the RFC, the people that invented email and said this is how email is going to work and provided that as the regular expression, said this gives you false positives and false negatives. So even all of that is still not correct for what they designed as the rules for regular expressions, or for what they designed as far as what is valid or not valid for an email, right? All right, so let's do some learning now. So what I'm going to do is I'm going to break down the little parts of a regular expression into little pieces, and then those little pieces are, once you understand those, you'll understand like 95% of what you can do with regular expressions, and it starts getting a lot easier to read and understand, right? So we've got letters and numbers, right? So they match letters and numbers, right? So this first example, /a/ is going to match a string that contains the letter A, right? And /7/ is going to match a string that contains 7, and I'm sure you can figure out all of the rest of the letters and numbers and how they match. So what if we want to match a word? Well, we just type the word, right? So this will match a string that contains the word regex, which is, you know, helpful. But so far, nothing is really special, right? You can do all of this stuff with normal PHP functions like stirpause or stirter or whatever, however you pronounce that one, or the other one that I can't remember right now. If you want a choice between multiple things, you can use a pipe. So this will match a string that contains either steak or pizza or cheeseburger. So this is all really, really simple stuff, and I would recommend if this is what you're actually searching for, maybe regular expressions is not the right tool for you. So let's talk a bit about delimiters, right? So notice at the beginning and the end of all of the patterns I've shown so far, we have a slash, right? We have to tell the regular expression where to start and where to end, because there's also some flags that we can add to the end that modify its behavior. So when you see those slashes, those are delimiters. They're not actually part of the pattern. They're saying the pattern is in between here. And with PHP and with other languages, you can choose to use a different delimiter, right? So this is also a regular expression that's perfectly valid, and it says that the delimiters are the pound sign or hashtag or whatever you want, octothorpe, right? We can also do character matching, right? So character matches say anything that's inside of square brackets, we're going to match one of the characters that's defined there, right? So in this first pattern, we've matched upper and lower P, upper and lower H, upper and lower P, right? So we're going to match PHP no matter what the case is. It could be capital P, lower H, capital P, or all lower or all upper, or any mixture of upper and lower cases that say PHP. We can also define ranges, right? So we can say, here's the whole alphabet inside of square brackets, which means we're going to match a string that contains any of the letters, or we can shorten that by using a dash character to say this is a range. So this A to Z inside of square brackets is identical to the first example where we have all of the letters spelled out piece by piece. And it's probably a good way to save some space and make people not angry with you when they look at your regular expression. Oh, I got a question. All right, check it out. I can put you up on the screen, right? So Heath's question is, how do you define which delimiter you want to use? The easy answer is you just use it. So when you use the function and instead of using slashes, you use pound signs, it's smart enough to go and say, oh, that's the delimiter we're going to use. So as long as it finds a matching delimiter at the end, that's the delimiter it is. If you put, if you started with a pound sign and then you didn't have a pound sign for the rest of your irregular expression, you would run into an error. So thank you. So that's what happened. That's what happens. It's pretty cool. There's another question. Do you have a preferred favorite delimiter? It depends on the situation, right? If I am matching a string that has a lot of forward slashes, I might not want to use forward slash as my delimiter because then I would have to escape my forward slashes. So I use it on a case-by-case basis, but usually it'll be either forward slash or pound sign because those are probably the most common ones. So thank you. All right. Continue on, character matching. We have character ranges, right? You can combine character ranges. So in this top example, we have capital A to capital Z, we have lowercase a to lowercase z, and we have 0 to 9, right? Which is going to match all the letters and all the numbers in the English language, right? The bottom one, we have capital A to F and lowercase a to F plus 0 to 9, which means we'll match any hexadecimal string or any hexadecimal character, right? We can also invert that. So we can say, I want anything except for what I've included in here. And you do that by putting a caret at the start inside of your square brackets. So caret 0 to 9 will match anything that's not 0 to 9, anything that's not a digit. Caret space will be anything that's not a space. And we can also match punctuation. And it seems like it ate something. Oh, so I think the idea here is caret is not at the beginning, so it's not special. So this just matches stuff. But if you put it at the beginning, it says invert whatever's in here. Does that make sense? Cool. All right. Word of the wise. Capital A to lowercase z is not the same as capital A to capital Z and lowercase a to lowercase z, right? The reason why is if you look at an ASCII table, what you end up with is all of these other characters. Those are the special characters that end up between the uppercase Z and the lowercase a in ASCII, right? So I have an anonymous question. How would you include dashes in character ranges? So there's a couple of ways that you can do that. One would be that you escape the dash, so you put a backslash inside of the character in the square brackets, or you can just put it first. So if you put it first, there's nothing to range against, and so it's smart enough to know that it's not meant to be a range from nothing.
Or last.
Or last, yeah. So as long as there's not something before and after, it's not going to think it's a range. All right. So anyway, I had never seen people do that until I was looking at more stuff yesterday, so this is one of my new things from not 2014. All right, special characters. We have a dot, which represents any character, right? And if we do 2 dots, it means any 2 characters, right? So this is where things start getting a little bit tricky, right? If you wanted to allow a user to input an email address, for instance, it has dots, and you just throw that into a regular expression, you're going to potentially find other things where those dots might be some other character, right? So in order to actually match a dot, we escape it. We say, put a backslash in front of it, or we can put it in a character selection where it doesn't mean any character, right? So if you put it in square brackets, it means just dot. Because it wouldn't make a whole lot of sense to say, here's a character selection that matches any character, right? That's just typing extra for no good reason. We have character classes. Character classes are pretty cool too. So we can do \d, which represents digits. But at the bottom here, you can see these are also digits. These are digits in other languages and other Unicode code points or whatever. So if you do \d and say you're matching a phone number, or you're matching social security number or credit card number or whatever, or you're doing it for your own input sanitation or validation or whatever, and you use that, these other things all will pass that regular expression check as well. So if you really mean regular 0 to regular 9, you might be better off using that as an example. And then the invert of that is the capital one. So backslash capital D is anything but those digits. We also have word characters, which is backslash W. That's the shortcut for all the letters and the numbers. And the invert of that, or the opposite of that, is capital W, backslash capital W. We also have space, which will match space, tab, new line, and line return. And the opposite of that is, of course, capital S. We can do repetition. So if we want to do a thing multiple times, we can just repeat it, right? So the first example is 2 digits in a row. The second one is just our standard Arabic numerals in a row through character ranges. Or we can use curly brackets and say, we want this exactly 2 times, right? So anytime you put a repetition marker, you put this curly bracket following something, it'll say, we want this however many times. And you can do a number of things with that, which I'm pretty sure I have a slide coming up on it with how else you can do the ranges. And then there's shortcuts for these as well. So if you use the plus character, it means that I want at least one of these, but I'll match as many of these as you can give me. So that top example here is I want to match 1 to however many digits in a row that you can give me. If you're not sure if it's going to be there, then star works for that. Star is 0 or more. Okay. Here's some more. So I explained those two. If you say I want exactly some number of it, then that's where you would do curly bracket X. If you want 1 or more, you would do curly bracket X followed by a comma. If you want up to a certain amount, you would do comma followed by however many you want up to. And if you want to match a range, which is inclusive, you would say from X to Y. Now, it is important too to note that there are no spaces in there, and spaces will screw this up. And you'll end up spending a good amount of time trying to debug and figure out why your regular expression is doing weird things that you weren't expecting. Additional special characters. If we have a question mark, it says whatever we just said, whatever we just matched on, which could be any of these things. Could be character selections, could be word, could be a group of things. Whatever that whole thing was is optional. We don't have to match it. So this is kind of the 0 or 1 matcher, right? So let's break this one down step by step. So here's another regular expression, and we're going to go piece by piece, chunk by chunk, and explain what all of this actually means, right? So first of all, we've got our opening delimiter, right? That slash is just a delimiter. It's not part of our pattern. So we're gonna kind of like move beyond that. Our next part, we have backslash parenthesis question mark, right? So parenthesis is a special character in regular expressions. So in order to match it, we have to escape it. So that's the backslash, and it's escaping the characters to say we want to actually match a parenthesis, an open parenthesis, and then the question mark says we don't have to have it though. We'll match it if you have it, but if you don't have it, that's okay too. The next part, we've got now a matching set of unescaped parentheses. So this is a capture group. This means that we want to actually hold on to whatever pattern we find within this match, so we can do something with it later, right? And within there, we're matching backslash D 3 times, right? So we're saying, I want to match 3 digits. And then because we've got that capture group, we want to keep it. We want to hold on to it for some reason. So now we've got another special character, but it's escaped. So our closing parenthesis, and it's optional again. So we've got an optional closing parenthesis. Following that, we have, remember this is the character class for space. So we've got any sort of space character or a dash, and that's optional, okay? The next section, again, should look pretty familiar. It's pretty much the first one again. We're going to capture and match 3 digits. And again, both of those are not have that in our pattern for it to match. And then we do the same thing, optional space or dash again. And then we do 4 characters, and we're capturing that. So that's another non-optional part of this pattern. And then our last part is our closing delimiter, right? So what that matches, if we put all this together, is it'll match phone numbers in all of these different formats. And it'll match them in a lot of other formats too, but it'll match most common kind of normal phone number patterns, I guess. Which is kind of handy, right? I know for me, if I go and I type stuff into a web form and it's telling me, no, you've typed it wrong, like you didn't do it the way that we said you should for a phone number, for social or credit card number or date or anything, where it's like, why do you care? I gave you the numbers you care about. It's pretty frustrating. So when we program stuff, we should make it so that we are accepting as much as we can in as smart of a way as we can. All right, so that does not match if we wanted to do dots for delimiters, for instance. Like this is another fairly common phone number format, but our regular expression we went through would not match that, right? We could go and add it and say, where we had that space character, we also want to add dot. But then other people could come up with like, well, I want to do hashtags as my separator or whatever, right? So one of the ways that we can do that is we can say, well, you know what, I'm going to take and replace everything that's not a digit, and then I'm going to see if I got 10 digits. And again, this is fairly US-centric, right? Because we have 10-digit phone numbers. You would want to have different rules if you're supporting international phone numbers. But we can do that. We can say, all right, I'm going to match everything that's not a digit, right? So we have this character matching group that says not whatever's in here, no digits. And I'm going to take whatever I find there and replace it with an empty string for my potential number. And then I'm going to say, if it's 10 long, then it's valid, right? Or it's potentially valid, I guess, right? It looks like it could maybe be a phone number. All right, let's talk about regular expression anchors. And I'm not seeing it like, so the other part, like you can also ask questions here too. You don't have to do it through the app. So if you have questions, please feel free. Yes, sir.
Is there a way to do a range like A to Z except for Q?
So the easiest way would be the letters A to R and S through Z. No, R through Z. A to P. Yeah, you're making me alphabet. You're making me alphabet on the fly, and I'm not doing well at it. But yeah, so you would just leave it out.
Break it into the front and the half rather than.
Yep, I would break it into 2 ranges most likely. Yeah, it'd probably be the most straightforward too, because it would be fairly obvious that that one is missing. I mean, you could also spell all of them out and just leave one out, but then or scramble them. The regex engine is not going to care that they're in alphabetical order. But as far as you or future other devs looking at it, they might care and they might try to find you. All right, so let's talk about anchors. Anchors are things that we can use to specify where something is occurring in the string. So if we use a caret, and again, this is a caret outside of the character matching set. So say like at the beginning of our match, it says it's going to match the beginning of a string, right? So if we say caret AB, it's going to match A, B, C, D, E, F, G, because it starts with AB, but it's not going to match the AB in cab, right? But it would match the AB in absolute, right? Similarly, $ matches the end of a string, right? So if we do there, we would match AB or cab, but we wouldn't match the start of the alphabet. Does that make sense? And we can combine those things and say we want to start and end. We want an anchor at the start and an anchor at the end, which means that this part is going to match something that consists only entirely of lowercase letters, right? So if you throw a space or a number or anything else, it will not match because it will not be able to get to the end or the beginning of it. Those come later. Thank you, Heath. Those come later, though. All right. Okay, word boundaries. So \b is a word boundary, right? So what that matches is before the first character, if the first character is a word character. So the nothing space, like the not a character before you begin a sentence. It will match after the last character if that is a word character, and it will match between 2 characters if we move from a word character to a not a word character, right? So remember, word characters were A through Z and 0 through 9, I believe, both cases. So if we match with a word boundary beside fish, it's going to match fish, but it's not going to match fish if it's part of a word, like fisherman or catfish. But if we only put it at the end, it means that it could match fish, it could match catfish, but it's not going to match fisherman because there's not a word boundary there, right? Fisherman has R to, or has a H to E, which is not a word boundary. We're still from a word character to a word character, which is not a word boundary. We can do alternation, sort of touched on this a little bit before, but we can match either cow or boy or cowboy by using the pipe character. And we can say, I want to match with the word boundary on either side and match literally only cow or boy, but not cowboy, because cowboy would not have a word boundary after one of those matches. Does that make sense? All right, so by default, regular expressions are greedy, which means they're going to match as much as they possibly can. So let's say we wanted to find the opening HTML tag, the opening H1 here. So we do a regular expression here that says, I want to match a less than followed by one or more something characters, anything, I don't care, followed by a greater than, right? Well, with regular expression, this entire pattern of welcome to Denver PHP with the H1s around it matches, right? Because this is going to match here, and it's going to capture everything up until here, and that's our entire match. That's not what we want. We want only the opening thing. How does so how do word characters and boundary matching work with Unicode text? I believe they work as you would expect them to, meaning if it's a word character and not something special. So in other words, like A to Z would be the simplified version of it, but there's a whole lot of other Unicode characters that would also count as word characters. So it will match when you move from something that isn't that into it or from that out of it, if that makes sense. And I would recommend taking a look at the regex page on PHP for the exact behavior of it. And we can also play around with it here in a bit as well. All right, so we want to figure out how to make our regular expression lazy and say, hey, just go ahead and stop once you've matched. Once you can potentially fulfill this pattern, just stop. Don't keep going, right? So what we do there is we follow our repetition marker with a question mark, right? So yet another use of question mark. So instead of it saying, I want one or more, as many as you can give me, it's saying, I want one or more, as few as you can give me. And in this case, it's going to match just the opening H1 tag. Now this is not necessarily the most efficient way to do this sort of thing. Another way that we could do this is we could say, let's match the less than followed by however many not greater than characters we can find, followed by a greater than character. What this means is we're not going to backtrack if we run into a situation where we haven't matched. And backtracking is something that can potentially kill performance in regular expressions, but it's essentially saying, okay, we went as far as we could, we couldn't match this thing, so we're going to back up and try from an earlier point. And you can actually, this is not in the slide, but you can end up coming up with a regular expression where the performance is absolutely abysmal because it will backtrack over and over and over. And it's very, very simple to create these sort of regular expressions, which is another reason why I'm saying, like, probably you don't want to take user input into a regular expression. It's trivially easy to crash a regular expression engine with what they call a regex bomb. So if you're interested in how to make those, just Google it. It's there. It's like 10 characters or less. It's very, very simple, and it essentially says, like, we're gonna go and match this repeating group followed by itself optionally, right? And it will do a bajillion checks on this thing to try and match something, and the bigger your input is that you're checking against, the longer it will run, and I believe it's exponential time. So it's a really not so happy time for the computer that you're running it on. I think we accidentally did one when I was presenting this a few years ago. There's a RE fiddle had come out, and we were like, I wonder if they detect this, and we went boop, and the whole page went down. So we killed the site, as far as I know, accidentally. It was not on purpose. All right, so let's talk about capture groups. We want to capture a part of a regex so that we can use it, and this is done through back referencing, right? So in this example here, we've got 2 underscores followed by a selection between construct or destruct, right? So in PHP, we're looking for a constructor or a destructor, right? And what we do is we capture that, and then we can use that later, and we can say, which one did I find? I can do a conditional on it. I can say, did I find a constructor or did I find a destructor? What do I want to do with it, this thing that I found? And we can also reference that captured part within our pattern itself, right? So this bottom example, we're matching lowercase a through z one or more times, followed by that exact same thing again, right? So what this means, this is similar, it's not exactly the same as one or more, but we're saying I want to match a through z 3 times, followed by that same thing again, right? So we're going to match 3-letter repeated things like bam bam or boo boo or whatever, you know, come up with your own example. As long as it's lowercase and the same 3 is repeated, that will match. So let's talk about why, or practically why we would use it. So this this regular expression in the preg replace call is the phone number one that we talked about earlier, or should be very, very close. I've noticed that sometimes Google Slides is eating characters, and I've tried to replace them as much as I can, but every once in a while they're gone. And so what this does is in one shot, it takes that kind of you know, loosey-goosey, give us whatever format you want, and reformats it back into this bottom format here, right? So we've got the area code in parentheses, followed by a space, followed by the exchange, followed by a dash, followed by the last 4 of your phone number. And it does it in one shot, right? Which is kind of neat. Here's another one. So we've got a word boundary followed by some word characters, followed by some space characters, followed by that same word that we captured, followed by a word boundary, and we're going to replace all of that with whatever word we captured, right? So we can use that, that \1 is referencing our first capture group. So unlike, you know, every other place in normal programming where we start with 0, in regular expressions we start with 1 because reasons, I guess. So that's just something to be aware of. And it's like the capture group is as you start the opening parenthesis reading from left to right, right? So if we had multiple ones, which we'll see here in a bit, that's how you're going to see those capture. And actually, I think here it had it, right? So we've got a capture group here, a capture group starting over here, going to here, and we've got a capture group here, and we're referring to those as 1, 2, and 3. Okay, so what that does is it allows us to run a chunk of text through it and replace wherever we may have inadvertently repeated a word, right? So in the first sentence, I've got that repeated, and the result of that would be that that would be removed because it's duplicated. All right, so what if we want a group of things so we can do things with it, but we don't necessarily want to capture it? Well, in that case, we can use the question colon inside of the parenthesis, and that will say this is a group, but we don't want to capture it. We might want to do something with it, like repeat it or make it optional or make it a certain number of times matching, but we don't need it in our final result. And so what we're doing here is we say, all right, this in the blue parenthesis is our optional capture group, right? So we're saying inside of here we're going to do something. We're going to match 1 to 3 digits followed by an actual dot, and then we're going to do that entire thing 3 times, right? So we're going to have 1 to 3 digits followed by a dot, 1 to 3 digits followed by a dot, 1 to 3 digits followed by a dot, and then we're out of this section and we're going to match 1 to 3 digits again, and then we're going to capture that entire thing that we matched, right? So this is a not great way to match IPv4 addresses, right? Because we're not worried about that, you know, 643.219 whatever, right? We're not worried that it's actually legit. These are matching the kind of IP addresses that you might see in movies and TV shows, right? That are larger than 255 for any of the octets. All right. So I think I just explained that without using my slide, but that question colon is how we make it a non-capturing group. We could do pattern modifiers, right? And this is where I was talking at the beginning, why we need those delimiters, because we can modify things. So we may not want to specify all of the cases of a letter, right? If we don't care if it's upper or lowercase, we don't necessarily want to say capital A to Z, lowercase a to Z, or whatever. So what we can do is after the closing delimiter, we can put I, and that makes the case, it makes it case insensitive when it's matching. We can also put on M, which will make it multi-line. We can put in an S, which means that the dot is going to match everything, including new lines. So earlier when I said it matches everything, it's almost everything. It doesn't match new line unless you do this thing. And then X allows us to ignore white space. And what that means is we can actually make our regular expressions kind of spread out. So instead of trying to jam everything into this line noise looking mess that's really hard to understand, we can actually spread it out over multiple lines. We can add comments and things to say, here's what this part is for and what we're doing with it. And you'll see that here soon. We've also got capital D, which says that the anchor is going to match the end of a string only. So in other words, by default, that $ ending anchor is going to match right before a new line if your string contains new lines, and also the very end of the string. This makes it match only the end of the string. So if you're looking for, like say you're using regular expression to match something, you say, I want a person's name to only be uppercase characters, right? And so I put in caret, uppercase characters, and $. They could give you input that's, you know, Tom in all caps, followed by a new line, followed by whatever else, and that regular expression without the D would match that, and it'd say, yeah, that's all good. This D says it has to be all the way at the end. The entire string is what we want to match. And then U says we're not greedy by default. So instead of doing plus question mark, we can say U, and then everything that would be greedy is lazy, and everything that is lazy would be greedy. There's other modifiers as well, and you can go into the PHP manual to find those. All right, so we've got capture groups, right? And what I was saying before is they're going to be in the particular order that you did them in, right? Which is sometimes useful, but sometimes not. Like if you're developing a regular expression and you start referencing things, and then later on you're like, oh, you know what? I need to capture this additional thing, and it's not the last thing. You don't want to necessarily renumber everything to make it work. So you can use named capture groups, which will allow you to put a name on whatever it is. So this is a combination of showing you the X thing that says we can put white space and commas or comments in here, along with named capture groups, right? So I've put the opening delimiter here at the top because it's the opening delimiter, we don't care. And likewise, I put the closing delimiter down here with the X. It says this is all going to be white space, but ignore it. Ignore the white space, ignore in white space again, including new lines, right? And then every part of this, we're now commenting what it is, right? So kind of like what the slide showed earlier, what each of these pieces mean, I could put this right in my code and this is legitimate and it will work, right? Now the thing to keep in mind is, since we're ignoring spaces, if you actually want to use spaces in your pattern, you need to either put it inside, you know, a character group or use \s for the space character group or something like that, because otherwise they're ignored, right? So in a one-liner or in a single line regular expression, a space is a space, and you can match on it. Not when you use /x, or not when you use the X delimiter. Does that make sense? All right. So what we get out of that when we run that phone number through without any sort of delimiters is each of these pieces gets broken up into this array, right? And we still get the numerically indexed pieces, but we also get whatever our named capture groups were, right? So the thing that was after, I didn't even talk about that. That was stupid. All right, let's go back here. So we have question P followed by angle brackets followed by whatever name it is you want to use, and that's what's going to come out in the result of your regular expression with your named capture groups, which means that you can actually have meaning behind it. Even if you do this in one line, I think it's better than trying to use indexed or numeric associative arrays on your output. So anyway, that's what you get out of it, right? And it tells you like, oh, this is what we think the area code is. This is what we think the exchange is. This is what the number is, right? And they're all split up into separate parts that now have a word associated to them, and we can use that word. So even if I were to go and say, you know what, for whatever reason, I want to capture maybe the dash that happens between the exchange and the number, if it's there, that doesn't affect what the number is going to be called. It'll change the actual 3 in the index or whatever here, but the number or the exchange won't change. All right, next we have positive lookahead matches, which is we want to find a pattern that is followed by another pattern, but we're not actually wanting to capture the other part of the pattern, right? So positive lookahead matches are a capture group that is modified with question equals right here. So in this case, we're looking for something with a P that is followed by an H, which means it'll match phone and fish and telegraph, but it's not going to match potassium, right? Yes, sir?
Directly followed by an H, or anywhere later followed by an H?
Directly followed by an H. You could do more complicated things in there. You could say like dot H, and it would be, or dot star H, and that would say P, and then if there's an H anywhere else, like don't want. But this is directly followed by an H. We have negative lookaheads, which is kind of the opposite, and that's designated with a question bang. So that would be P not followed by an H. So it would match potassium, but it wouldn't match telegraph or telephone or any of those things. So lookaheads, they don't capture anything, but they determine if we have a match that's possible. They are zero width, which means they don't take up any space in our result, and they're not moving kind of the, if you think of how the regular expression might match, like looking at character and character to see what matches, they're not going to move anything around. And because of that, these patterns are not the same, right? So this is P followed by a character that's not H, whereas the second part is P that's not followed by an H, right? And you can kind of tell the difference in the English of it, right? The idea of P followed by something that isn't H is different than P that doesn't have an H after it, right? I could have just P and it would match the second one, but it wouldn't match the first one. Similarly, on the last one, PH is not the same as P followed by H. Does that make sense? It's a little bit weird, and this is kind of moving into the intermediate advanced area of regular expressions, and you probably won't need to use them very often, but when you do, they're super helpful. We also have look behinds. So those are happily delineated with the question less than equals, which is kind of, think of it as like, look that way, you know, this is where we want to look. So if we do that with an OO, we say, I want a D that had 2 O's before it, right? And a negative one, very similarly, but we swap out the equal sign for a bang, and we say, I want a D that doesn't have OO in front of it. But again, we're not capturing the OO or whatever is before, we're only saying the pattern can't have that before it. All right, so if you're building regular expressions, test them very thoroughly, especially before they go to production. You can, you know, again, if you have user input going into your regular expressions, you can seriously hose your site, or they can, on your behalf, hose your site. It is a lot easier to get a regular expression wrong than it is to get it right, but it's not terribly hard to get it right enough. And then I would recommend using tools like Sublime, like Atom, like PHP Storm or Regex 101 to test your regular expressions. And I'll show you some of these here shortly, but they are super awesome when you're trying to figure out how do I make this work or why isn't this working? Because you can put a regular expression in these tools and then say, okay, this isn't working, why isn't it working? And start taking stuff away until it starts matching, and then start adding it back again, or saying, oh, I forgot about this case, right? Like there's an extra space here that I didn't account for, there's something else. So using those tools are awesome. And the PHP Storm one is not one that I use very often, but it's pretty neat, and I played with it yesterday, and I could probably show that. When should we not use regular expressions? Well, when they're not needed, clearly. If you can do the same work using stir pause or stir or stir replace, totally do that. It's way faster, and way less prone to causing a problem. If you can't use those because the pattern is more complicated or whatever, and you can't just say, this is what I'm looking for and this is what I want, then maybe regular expressions are what you want. And then if you're actually needing a parser, don't use regular expressions. Make a parser for it. So a couple of resources. Regular expressions info has been around forever, and they will go deep into the nitty-gritty of regular expressions. It's a good course. The PHP manual is pretty good on that as well. There's Regex 101, which I'll show you here shortly, I think, and RE Fiddle. And the neat thing with those is, especially with Regex 101, you put in your own pattern and your own kind of thing you want to test against, and it will break down each of the parts and say, this is what it's looking for when you put this in, and it will highlight on the match what part matches what. It's also got a debugger, so you can say, well, why does this cause a regex bomb? And it'll show you, here's the 2,700 steps we went through before we determined that we couldn't match or whatever. Or here's the 75,000 steps we went through. Here's the credits for all the photos that I used. They're all Creative Commons, Flickr stuff. Any other questions? All right. So I'm going to put Regex 101 up. We can look at that. I'm going to try to put Regex 101 up. Okay. Do I have... unmirrored, maybe mirrored. I think I'm mirrored now. Yep. All right, Regex 101. Okay, so we could take whatever we want again. So let's put in a phone number, and I want to match that. Right? And maybe I want to match, maybe I want to match a bunch of different phone numbers. So I want to see a match on every single one of these. So if I start typing my regular expression, I say, oh, okay, there's D, it matches all of those things, right? This is probably too small to see. How is that? Better? All right. So it's matching all of those things, but we want to match more than all of those things. So let's match, 3 of those, right? So we'll say there's 3 of them, and now we've matched all 3, all sets of 3. And you notice even here where we've got 4, it matches those as well. And this is the cool part I was telling you about, right? This is explaining, right? We must match a digit equal to 0 to 9 3 times, right? And it'll break it down into English what it is that you've done. So if you've got a regular expression in code and you're like, what in the world is this doing? You could drop it in here and it'll explain what's going on, and you can put in your own kind of test against it and see, is it matching what I think it's matching or is it not, which is pretty awesome. So now we've got a number of things. So let's say I just want to start matching the first one. I want to make sure that one matches. So we'll say, all right, we're going to match a dash. I don't know that I have to escape it. All right, in that case, I don't need to escape it. So now, notice I've got 3 sets of matches, but I want to start and get my next 3. So we'll do that. So dash D 3 times, and now I've matched my area code and my exchange for the first one, but I've matched my exchange and the first 3 for my second one, which is not what I want. So we'll add in one more, and now that works. Great, right? So I've matched one of them, but I want to match all of them. So another thing that's great about this is you can have unit tests in here. So we can add, we can say, I want to match number with dashes, right? And my test string is the same thing, and we want to make sure that it does match. So I can run my test and it says, hey, great. So I'm going to save that, and now I've got that in place, and I'm going to go back to my test area, right? And I can run all of my tests at any point and say, does it still match? And actually what I can do is I can say, you know what, let's add some more. We'll say formatted number. And we'll save it, and we'll add another test for just digits. We'll save that. And when I run it, you'll notice like I get one pass, but I get 2 failures. So my goal is, how can I make all of these things pass and be sure that it's still working, right? So let's go back to the test area. So on this one, I'm not matching a parenthesis, but I only have a parenthesis some of the times. So I probably need to add something here that's optional. So we can say, let's add an optional question mark. And that started here, but it didn't finish, right? So it's not quite there. But right here in this spot, we've got another, or right here, we've got another parenthesis, so we can add that as well. So say another optional parenthesis. And we're getting there, right? And now we've got a space, but in the same spot here, it's a dash, right? So this is like how, if you didn't have a plan to start with, how you could kind of incrementally get your way to maybe the regex that I showed earlier. So we're going to put this in a character group, and I'm going to go ahead and add a space in there. And so far so good. Now I've matched 2 of these, and if I switch back to my unit test, I think I should get 2 greens. Nope. I must have done something slightly different. Oh, I didn't put a space in. All right, let's add that in. So we'll say this thing is going to be optional. So we'll put a question there. And now I can run my unit test, and it probably will be better. 2 greens, woo, right? We'd say, well, this is probably optional as well. So let's put a question there. We'll run the tests, and that's working, right? And we can continue iterating on this and adding additional examples of other phone numbers and other phone number formats, and building this regular expression and making sure our tests are passing, making sure that it's matching. And you notice here, we're still not matching this one, but I didn't have a test for it. So let's add that as a test. Now I've got 3 green and a red. So in that case, I still potentially need a dot. And in the test area, we can see nothing happening. Why is nothing happening? It's inside of here. Sorry, was there another? Oh, there we go. So now all of my unit tests should be happy and green and running. So there we go. RE fiddle works pretty much the same way. So it starts with this match that says I want a K followed by not spaces 0 or more times followed by an S, and it matches a couple of kittens. I didn't put this in. This is what happens when you go there. Another useful, kind of pretty cool tool in Regex 101 is somewhere. Kind of thinking it might not be happy at this resolution. Oh, there we go. So you can also switch what flavor of regular expression. So if you're using JavaScript to do regular expression and you want to test, things may be slightly different. Also Python and Golang. But in here we can do a regex debugger, and you can see how many steps does it take to find the matches for this, and what is it looking at, right? So it starts out at the beginning. It's saying now we're going to match this optional question followed by 3 digits and so on, and you can see what it's capturing and what it's doing while it's moving along. And so this is how it finds the first match. These are the steps that it has to go through for the second match and the third match, and then at this point it's starting all the way at the end of our string, and it takes 3 more steps to find that there are no more matches, right? And so if you were to find a regex bomb, for instance, and put that in there, you're going to see a ridiculous amount of steps in order to determine that it can't match. So, all right. Anything else? That's all I got about this.
Can you do an example with the lazy versus?
Sure. All right, so let's, if it's all right, I'll use the HTML example from earlier. So I want to match just the starting bracket, or the starting tag, right? So we start with the open part of the tag, and we'll say, I don't know what the tag is. We could say we do. If we want to match H1s, that's fine. But I'm going to say, I don't know what's in there, so I'm going to say there's some sort of a text, and then we're going to have not that. We're going to have the closing tag, right? And you notice it matches as far as it can. If we put the question mark after the plus, now it splits it, and we get two potential matches, right? So it says stop as soon as we can fulfill this. So if we look at the debugger on what happened with it, we have the first match in 6 steps, right? So it matches our curly bracket. It matches as few anythings as we can until we match our closing angle bracket, and then we're at the end of the match. We're at the end of the pattern, and we're done, right? And then our second match, we're continuing on from right before the W and welcome, and it's looking to say, when can we start matching this open angle bracket? And it takes it, looks like 20 steps to get to the point, which is probably 20 characters or something, until it gets to the point where it says, oh, hey, here's another one. And then it goes through the same sort of a process, and it's trying to match as little as it can to get to the end. So if we switch it back to not into greedy, and then look at the debugger, 6 steps, right? Is all it takes. So behind the scenes, like how this is all happening is finite state machines, which is a whole different topic. But it may help you have some insight into what's actually happening and how to write a good regular expression or how to write a bad one. But it's kind of cool. There's actually an article I read fairly recently where somebody was talking about solving Pokemon Blue with a regular expression, because it's all like, it's a finite state machine, and regular expressions can represent a finite state machine. So it was an interesting talk or article. Yes, sir?
Do you know if this debugger is that necessarily what PHP does with this regular expression engine?
I don't know for certain, but I would not be surprised if it's pretty much what it does.
As an example, on that particular one, say Denver was in a span tag. How could you do the regex to only find nested tags?
Let's see.
You can do that on the fly. Yeah,
that's a slightly different problem. I don't know if I can even type a span tag. I need to eat some food. So essentially that.
Yeah. So I wanted to find like the inner tags, whether it's span or whatever, but not find the parent tags.
Okay. Let's give it a shot. So if I go there, that's finding all of our tags, right? And let's capture that. So there's that. So now we've captured the word part of the tag. And then we want to have some stuff. And then we want to have a closing, we want to have a closing tag that matches that. And let's see. So there's that one. I'm trying to think if there's a way. So this is kind of going into the, you might need a parser, right? But we've captured this one, right? It won't match if I don't, or it won't match the H1 if I change that, right? So now I've got mismatched H1 to H2, but it does find the matching span tags within there. But it's also not going to detect like incorrectly nested tags. So if I put my span here, and I put that back there, it doesn't, it's not going to detect that. I'm not 100% certain that you can do this with regex. You might be able to, but there's certain things that you can't really do. Like you can't reverse a string, like, or you can't reverse an arbitrary string, right, of arbitrary length, for instance.
So you could look at the string, you could do the capture and say, are there more than 2 tags? That would tell you that there's 10 nested or something like that as a possibility, but you probably couldn't capture.
Yeah, like I guess, yeah. What's the goal? Like to see if it's properly nested, or?
Well, you know, for example, if you want to not modify the nested tags, but only modify the parent tag or something like that.
Not modify the nested. So if I put this back to not broken, like this, and you want to modify the H1, but you don't want to modify the span?
So I want to say add a class to the tag, but I don't want to add a class to the span. I want to add the class to the H1.
In that case, this probably does it well enough for you. Again, it's not going to guarantee that it's going to work properly if you give it garbage HTML. But in this case, we've captured the H1. And if you were running this through a PHP function, you would be able to do something with that. And so you could say, all right, I know I've found an H1 tag. Now I'm going to use stir replace on this string and say, here's the H1, and I want, or here's the H1 tag, and I want to replace it with an H1 tag with this class. I'd have to think about it if I would say recommend that, but it would be doable. Let's see. I'm trying to think, and I'm drawing a blank if there's a way that I can have it like capture the entire string and then also capture within it, and I don't think I can. But one thing you could do is say, okay, I found the H1. I found the start of the H1 and the end of the H1. So now look at the resulting substring with that off of there and see if that matches, right? So in other words, your second look would be at this string, and in that string it would find the span tag if you wanted to do that route. Anything else?
Just for fun, if you copy first capture group, including the angle brackets and the dot star.
First capture group, okay.
So starting with the first angle bracket all the way up.
To there?
No, sorry, I was thinking.
Or do you want to capture the entire string?
I was asking you to just copy paste actually. So,
Oh, sorry.
Sorry about that. It's not being really clear.
Okay, there's that. What do you want?
So from first angle brackets, keep going through the star.
Okay.
And copy it, just paste it again right there.
Right here?
And then instead of a open closing -1, actually copy that again too. Stack it on the end and change the first one to a 2.
Yeah. So it's another one of those, like, in that case you've captured those, but now what if I, throw a monkey wrench at you and I say, well, what about that, right? And this is kind of along the same reasons of why we can't like reverse an arbitrary string. You could put a regex and say, oh, we can reverse a string up to 8 characters or up to 9 characters, up to 12 characters or whatever, but it's not going to go bigger than that unless we make our regex kind of bigger. This is honestly getting a little beyond where I feel comfortable speaking with any sort of like, this is the way it is, like, because somebody's going to see it and go, no, you can totally do this and it's this way, and here's the email regex and it does it 4 times in there or whatever, So I'm not going to say it's impossible. I will say I don't know how to do it. So, all right.
But you gave us a puzzle. It was just
Yeah.
stop.
Yeah, and if you kind of like, you could programmatically create this regex to say like, how many levels deep do I want to match? You know, and make a function that builds the regex that then runs through there. That would be pretty trivial to do that way, but I don't know if that's a good idea either. Seems like maybe not. But this does capture, like, this does work. This example here does work with properly nested tags and does not work with improperly nested tags, at least at the first two levels, right? So if I put the span on the outside, it's not going to match. However, if I screw up the closing U tag, I think it still matches because we don't care about that. That's part of one of those match anything 0 more times. So we know with this regular expression, at least to 2 levels, we're properly nested. So. Anything else? All right. Thank you all.